Hi students, this is 12th Mathematics, Chapter 6, Example 36. Find the shortest distance between two given straight lines. The first one is r vector is equal to 2a vector plus 3j vector plus 4k vector plus t into minus 2a vector plus j vector minus 2k vector. And another one in the form of Cartesian, x minus a by 2 equal to y by minus 1 equal to z plus 2 divided by 8. Now, I want to arrange either both straight line equation, either vector format or Cartesian format. I am going to write in vector format, right? Okay, now solution. Now line 1. So this is line 1. R vector which is equal to 2a vector plus 3j vector plus 4k vector plus some scalar t into minus 2a vector plus j vector minus 2k vector. And another line 2, I am taking line 2, and this line is r vector which is equal to, we want to check the numerator whether the x, y, z coefficients are plus 1. Here plus 1, here plus 1, here plus 1, no problem for that. So, in numerator, what are the numbers? You want to take the opposite side. You see, minus 3 is given, so you want to take plus 3, so plus 3a vector. In y, there is no term in the numerator, just 0, j vector. Another one, z, coefficient plus 2 is there, so you want that as a minus 2k vector, plus s into. Now, the denominators, 2 vector, this 2 you know, so 2 into I vector, here minus j vector, here plus 2k vector. In denominator, you want to take as it is, but in numerator, you want to change the sign. Now, I consider this one a1 vector. So a1 vector is nothing but 2i vector plus 3j vector plus 4k vector. a2 vector which is equal to 3 vector minus 2k vector. Here 0, so I leave it. And choose this is u vector. U vector is equal to minus 2i vector plus j vector minus 2k vector. And v vector is equal to plus 2a vector minus j vector plus 2k vector. You see here, the coefficients are I, j, k are multiples of the other. You see, v vector is nothing but minus of u vector. V vector is nothing but minus of u vector. You are multiplying u vector by minus, you get a v vector, isn't it? It seems that u vector is parallel to v vector. Hence, the lines are parallel. Hence, the lines are parallel. So now the lines are parallel. Now we want to find out the shortest distance between the lines. So we have the formula to find shortest distance. D is equal to a2 vector minus a1 vector cross u vector divided by magnitude of u vector. So whole modulus. So you take any vector, either u or either v. So if I take any vector, it will be correct. Okay. Now you have to find out a2 vector minus a1 vector. What is a2 here? 3 minus 3 vector minus 2k vector minus then a1 vector 2i vector plus 3j vector plus 4k vector. Now 3i minus 2i, this is nothing but I. Here minus, there is no j here, so you take minus here, so minus 3j. Minus k can go that side, minus 4k. So minus 2k minus 4k, this is nothing but minus 6k. Now I want to find out the a2 vector minus a1 vector cross u vector. If we take cross, what we use is determinant format. So determinant I vector, j vector, k vector. I took either u or v. I take only u, so consider u. This is nothing but minus 2. 1 and minus 2. Before that, we know that the a2 vector minus a1 vector coefficients, so 1 minus 3 and minus 6. Now you want to find the value determinant here. So I vector minus j vector plus k vector. Right? So ith minus, you want to make the ith row and ith column, you get a minus. This diagonal is nothing but primary diagonal and this diagonal but secondary diagonal. You want to multiply this one, minus 3 minus 2 plus 6. 1 into minus 6 minus 6, you want to change this symbol plus, so plus 6. And then now you want to make the jth column, the jth row, then you get the minus 1 minus 6 minus 2 minus 2. You want to multiply this one, minus 2 into 1 minus 2. Minus 2 into minus 6 plus 12, you want to change the symbol, so minus 12. Now you want to make the kth column and the kth row, so we get the minus here. So 1 is a 1, minus 2 into minus 6 plus 6, you want to change the symbol as minus 6. 6 plus 6, 12, so 12 into I vector. Minus 2 minus 12 minus 14, so minus of minus 14 plus 14, so 14 j vector. 1 minus 6 minus 5, so minus 5 k vector. Okay, now I want to take magnitude. Magnitude of a2 vector minus a1 vector plus u vector is equal to square root of 12 square plus 14 square plus of minus 5 whole square. So this is 144, this is 196 and this is 25. Next, you want to add it 144, 196, 25, 4 plus 6, 10, 10 plus 5, 15, so 5, balance 1, 5 plus 9, 14, 14 plus 2, 16, 6, balance 1, so 367, root 367. Next, magnitude of u vector. Magnitude of u vector is available u vector is nothing but minus 2, so minus 2 whole square and the plus 1 jth component and the kth component minus 2 whole square, which is equal to plus 4 plus 1 plus 4, which is equal to root 9. This is nothing but 3. Therefore, the distance is equal to magnitude of a2 vector minus a1 vector plus u vector divided by magnitude of u vector, which is equal to root 365 divided by 3 units. Okay? Hi students, this is example 37. Find the coordinate of foot of the perpendicular drawn from the point to the straight line. R vector is equal to I vector minus 4j vector plus 3k vector plus t into 2i vector plus 3j vector plus k vector. Also, find the shortest distance from the given point to the straight line. So, imagine that this is a point minus 1, 2, 3 and this is a line L1 is given that R vector something. So now a perpendicular line drawn from the point to the given line. This is a perpendicular. Now we have to find out the foot, the coordinate of the foot. That means we want to find out the points. So consider this is A and this is B. Now we have to find out the point B and this is line 1. Now this is the first question. Second question, the distance between a point and a line. This is the second question. So first question, what is the B? The second question, what is the distance between these 2 points? The point minus 1, 2, 3 and the foot of the perpendicular line. Okay? Right. So now solution. So this is given line, isn't it? So given line, I take the Cartesian equation of given line. Given line in Cartesian form. Given line in Cartesian form is this is the points, then is a vector. So x minus 1 divided by 2 and y minus 4. So y minus of minus 5 will be plus 4 divided by z of 3 and z plus 3 means minus 3 and this one by 1. Consider x minus 1 divided by 2, y plus 4 divided by 3, which is equal to z minus 3 is equal to 1 for some lambda. Now find out x. So x minus 1 divided by 2, which is equal to lambda, y plus 4 divided by 3, which is equal to lambda, z minus 3 divided by 1, which is equal to lambda. Then x is equal to, so 2 into lambda, 2 lambda. So 2 lambda minus 1 goes to that side plus 1. Here, y which is equal to 3 into lambda, 3 lambda. So plus 4 goes to that side minus 4. 3 lambda minus 4. Here, z is equal to 1 into lambda, lambda, minus 3 goes to that side plus 3. Therefore, the points x, y, z is equal to 2 lambda plus 1, 3 lambda minus 4, and lambda plus 3. Since this is a point lies on the line. Okay? Now, imagine that for some values of the point, for some value of lambda, the coordinate of b coordinate of b is what? B, the point is nothing but 2 lambda plus 1, 3 lambda minus 4, and lambda plus 3. Okay? So given points, given point is a. What is a? Minus 1, 2, and 3. Now I want to find out a vector. Okay? Now AB vector. I want to find out this is AB vector, right? So AB vector is equal to OB vector minus OA vector. What is OB? 2 lambda plus 1 into I vector. 3 lambda minus 4 into J vector. Okay? Then lambda plus 3 into K vector. Minus I vector plus 2J vector plus 3J vector. This one 2 lambda plus 1 minus plus 1 into I vector plus here 3 lambda minus 4 minus of this one minus 2 into J vector. Here lambda plus 3 minus of plus minus, so minus 8 into K vector. Simplifying we get 2 lambda plus 2 into I vector. 3 lambda minus 6 into J vector. Here lambda into K vector. This is nothing but AB vector. Now you see, this is a line. In this line, we have a vector, isn't it? The vector is nothing but 2A vector plus 3J vector plus K vector. So here, V vector is nothing but 2A vector plus 3J vector plus K vector. Okay? Now, AB is perpendicular to the line, isn't it? Implies AB vector dot B vector which is equal to 0. This is AB vector. Here this is a line. It lines contains a parallel vector, isn't it? It is a vector. So these two vectors are perpendicular. These two vectors are perpendicular means what? Dot product of the two vectors will be 0. What is A vector? 2 lambda plus 2 into I vector. Next one, 3 lambda minus 6 into J vector. Next one, plus lambda K vector. Dot. Now B vector. What are the B vectors? Integrate. We want to take from the line. Okay. So 2A vector plus 3J vector plus K vector equal to 0. In dot product, I dot I 1, J dot J 1, K dot K 1, I dot J 0. So same vectors, unit vectors dot product will be 1. Different dot product of unit vectors will be 0. So now we want to multiply with corresponding unit vectors coefficients, right? So if I j to j, K to K, the vector doesn't present because this is a dot product, the answer will come in scalar. Here what is the coefficient 2? So 2 into 2 lambda plus 2. Here plus 3 into 3 lambda minus 6. Here plus 1 into lambda equal to 0. Now we want to find out lambda. Multiply this one. 4 lambda plus 4. Multiply this one. 9 lambda minus 18 plus lambda equal to 0. This one lambda plus 9 lambda 10 lambda 10 lambda plus 4 lambda 14 lambda. Here 4, here minus 18. So 4 minus 18 minus 14 equal to 0. Then 4 lambda which is equal to plus 14, then lambda is equal to 1. Substituting the lambda value here, we get the fruit of the value b. Okay? That's all. At lambda is equal to 1. At lambda is equal to 1, the b becomes. B is 2 into 1, 2. Okay? So 2 plus 1, 3. 3 into 1, 3. 3 minus 4, minus 1. Here 1. 1 plus 3, 4. So the foot of the points. The foot of the line is 3, minus 1, 4. This is the first question about point B. We found that. Next one, we want to find out distance between AB. Now the second question is right. Also find the shortest distance between given point to the line. So shortest distance between your line to the point. That is AB. You know very well AB. In 10th standard itself we are studying that the distance between 2 points is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square. In 10th standard we have only 2 coordinate axes, 2D, right? Now D is 3D, so you want to add it z2 minus z12. That's all. So x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now we know what is the point A, so minus 1, 2, 3, and what is the point B? We have found that 3, minus 1 and 4. Now we want to subtract here. So subtracting here itself we get answers, right? Minus plus minus. Either we can subtract this, both will be equal. x2 minus x1 the whole square, that also correct. x1 minus x2, that also correct. Because of square it will be equal. So subtracting this one we get we want to change the sign now. So this plus minus, here minus plus, here plus means you want minus. You see the symbols are same, so minus 4. Here the symbols are same, so plus 3. Here the symbols are different, you want to subtract minus 1. So the answer will come like this: minus 4 the whole square plus 3 square plus minus 1 the whole square. Somebody giving plus 4 minus 3 plus 1 is less than what about it? Because both are same. Square root of 9. 14 square, sorry, 4 square 16. 3 square 9. Minus 1 whole square plus 1. So 9 plus 1 10. 10 plus 16 26. So root 26 unit. So this is the distance between a point and the line. Okay, thank you. Hi students, this is exercise 6.5, question number 2. Two line equations are given. We want to show that these two lines are skewed and also find the shortest distance between them. Right? Now, solution. This is line 1, r vector which is equal to 6a vector plus j vector plus 2k vector plus s into I vector plus 2j vector minus 3k vector. From this line 1, 6i plus j plus 2k, this section is nothing but point and this section is parallel vector. So, I take a1 vector which is equal to 6i vector plus j vector plus 2k vector and u vector which is equal to I vector plus 2j vector minus 3k vector. Now let's write line to 3 vector, sorry, r vector which is equal to 3a vector plus 2j vector minus 2k vector plus t 2a vector plus 4j vector minus 5k vector. So say this is point and this is vector. So I took a vector as 3a vector plus 2j vector minus 2k and b vector 2a vector plus 4j vector minus 5k. Now I want to show that these two lines are skewed. So to prove box product of a2 vector minus a1 vector, u vector, v vector not equal to 0. You are proving a2 vector minus a1 vector, u vector, v vector. The box product value is not equal to 0. Then the lines are skewed. Now I want to find out a2 vector minus a1 vector. So a2 vector minus a1 vector. So this is a1 and this is a2. Subtract a2 minus a1. 3 minus 6 minus 6. Plus 2 minus 1. So plus 1. Minus 2 minus 2. So minus 2. So this is a2 vector minus a1 vector. Now the box product of a2 vector minus a1 vector, u vector, v vector is equal to determinant of this one minus 3 plus 1 minus 4 minus 3 plus 1 minus 4 u vector is u vector 1 2 minus 3 1 2 minus 3. Next v vector is v vector 2 4 minus 5 2 4 minus 5. Now you want to visualize minus 3 into minus 1 into minus 4 into, okay, this is plus minus minus, okay, so minus into plus minus, here plus into minus minus, minus into plus minus. Now we are taking minor of minus 3 just to omit the row and the column. We get the minor here, just multiply the primary diagonal as well as the secondary diagonal. 2 5s are minus, 2 into minus 5 minus 3, 4 into minus 3 minus 12. You want to change symbol, so plus 12. Next, you want to find the minor of 1. You want to omit the respective row and the respective column. We get the minor. So this is the primary diagonal and this one is the secondary diagonal. You want to multiply with 1 into minus 5 minus 5. Here 2 into minus 2 minus 6. You want to change symbol plus 6. Now you want to find the minor of minus 4. Just omit the respective row and the column. We get the minor here. So 1 and 4. Multiply with this one 4. And this one 2 is 4. So you want to change symbol minus. So minus 4. Here minus 3. Symbols are different. 12 minus 10 plus 2 minus 1. Here symbols are different. You want to subtract 6 minus 5 plus 1 and minus 4. Here 4 minus 4 0. This one minus 3 into 2 minus 6. Minus 1 into 1 minus 1 which is equal to minus 7. This is not equal to 0. Hence the lines are skewed lines. So first question over. Now we want to find out the distance between the skew lines, right? So distance d is nothing but box product of a2 vector minus a1 vector, u vector, v vector, modulus divided by here man dot u vector cross v vector. Here box product of a2 vector minus a1 vector, u vector, v vector found already. So now we have to find out the u vector cross v vector. Okay. So now u vector cross v vector. So cross product means you want to write the determinant. So I, j, k. What is u vector? 1, 2 minus 3. 1, 2 minus 3. And then v vector 2, 4 minus 5. 2, 4 minus 5. I will show an idea to find the determinant of this one. Here I vector, here minus j vector plus k vector. Here there is no doubt. And take the numbers here. 2, 1, 0. Write it here. 2, 1, 0. This is the same value will be. Because instead of I, j, k, we are writing here minus 3, 1, minus 4. That's all. So inside the bracket, we have this value here. Okay. So doing that, 2i minus j Here 0, so leave it. This is U vector cross V vector. Now find value U vector cross V vector, which is equal to square root of 2 square plus of minus 1 whole square. Square root of 2 square is equal to 4, here 1, so root 5. Okay? Now the distance. Therefore, the distance is equal to the magnitude value is nothing but minus 7 divided by, and this one root 5. We have taken modulus here, so d is equal to 7 divided by root 5 units. So the distance should not come negative. Okay, thank you.